Hi everyone, I hope everything is going well. Back today just to do a quick video on differentiability. So this was the section we skipped over. The reason for that is I wanted you guys to have access to the derivative rules because it makes this section go a little more smoothly. So lesson 4.4, differentiability, essentially has a lot of similarities to the continuity section, where basically we have to show if a function is differentiable or not at a point. So first off, we had to be able to get the derivative. So algebraically, if we can get the derivative, then that's the first step. Right, so you use your derivative rules, see if the derivative exists. If it does, check. Then what we would have to look at is that function, that new function, and that function must be defined. So if we're dealing with a radical, right, we know that it's restricted, or if we're dealing with a fraction and x is in the denominator, we know there's restrictions there. So those functions would be undefined at certain points. Okay, so the formula doesn't work if the function is undefined. So the derivative got to exist, the function must be defined, and then this is kind of the tricky one. This is the one where in a piecewise, if you're approaching from two different directions, but they end up at the same point, then that point must have the same derivative. And I'll show you what I mean by that in a minute. So visually, when you're looking at a graph, you can look for these three things. So a corner point or a cusp are very similar. A corner just means you've got a line meeting with another line, so a V. A cusp just means one or both of these are a curve. So we could have just a slight curve going into a line, or we could have a curve going into a curve, and I'll exaggerate this one a little bit. So we could have this going into that. Now, obviously, I exaggerated a little bit, but essentially there's two curves there. Vertical tangent means the graph would essentially kind of flatten out vertically, right? So we could have something like that. And again, I exaggerated the graph. You'll see one of these in a minute. But if this shows up, if it's vertical, then it's not differentiable because you can't get the slope of a vertical line. And then point of discontinuity are the ones we're most familiar with. So that would be your POD, your jump, or your vertical asymptote. All right, so those are the things we're looking at visually. Now we're going to try to match those up to the algebra. So the first example gives us a corner point. Based on what I just said, this is an obvious corner point, line to line. It's the absolute value graph. But how do we show it algebraically? Over here, right, greater than, so from the right, and then less than, so from the left. If we took the derivative of each of these functions, they're not going to be equal. So we can show that. Take the right derivative. So derivative with respect to x of x equals 1. Take the left derivative. Derivative with respect to x of negative x. That equals negative 1. Okay, so in piecewise, you have to show basically where they meet, and if that derivative is not equal, then it's not differentiable. Right, so we can see they're not equal, so not differentiable. At x equals 0. The reason they're not differentiable might be hard to distinguish if you didn't have the graph. so we know it's a corner. But you're not always going to know that if you're just doing the piecewise algebra. Okay, so that's how you would use our power rule or our derivative rules to show if a function is differentiable or not. This is another one. This one's an example of a vertical tangent. You can clearly see this line goes vertically here. Algebraically, we've got y equals x to the third. So if we take the derivative of that, we would get 1/3 x to the negative 2/3. Now that gives me 1/3 to the positive 2/3. X is in the denominator, which means this function is undefined at 0. So you say, well, I can see the graph. Well, you can, but the derivative is a vertical line, which means, or the slope is the tangent is a vertical line, which means the slope is undefined, which means the derivative is undefined. The bottom one requires a new rule that we're going to look at called the chain rule. And I'm going to post the notes for that tomorrow, just to give you a couple of days. This is what your skill check next week is going to be on, the chain rule. So we're going to take Monday, Tuesday, Wednesday, and that's when you'll work on the chain rule. But I'm going to try to get those notes up tomorrow to give you a head start if you want it. Just to do one more piecewise. So this is another example of pointed discontinuity. These are clearly seen. There's a jump there. So the derivative is undefined at 1, not differentiable because of the jump. So piecewise, this one says show that f of x is not differentiable at 2. So all we have to do is very similar to what we did with continuity, is you would check the derivative of both of these at 2 and see what happens. So we do the left and right again. So the derivative of f of x, if we're doing the left one from the left, would equal 2x minus 1, which means the derivative at 2 would equal 4 minus 1, which is 3. The right side, we would do the derivative again. Now we could use quotient rule, or we could simplify, and that's what I'd like to do when there's only one term on bottom. We would get f of x equals 1 minus 2 over x, which is equal to 1 minus 2x to the negative 1. Now we do the derivative. So the derivative of 1 minus 2x to the negative 1 will be 2x to the negative 2, which means the derivative at 2 would equal 2 over 2 squared, or 1/2. So they're not equal, which means it's not differentiable at 2. So that's where the algebra comes in, where the power rules help a lot there, because you wouldn't want to use the limit definition on both of these just to get 3.5. Alright, so the f prime of 2 from the left is not equal to f prime of 2 from the right. And that's kind of my notation. That's not really a formal notation, but I like showing that because it shows understanding of what you did. Okay, if you have any questions on differentiability, there's not much practice for this. Is really just a small concept. So I'll give you the rest of today to take a look at the skill check. If you have any questions on that or differentiability, post them in the comments or email me. And the plan is to come back tomorrow with the chain rule stuff, and there might be a couple of videos for that one because that is a complicated topic when it comes to some of the questions. Okay, enjoy the rest of your day. Bye for now.